Good afternoon, all. Let's start talking of the pointers with the next concepts. So it's a second lecture on pointers. We have already discussed the pointers in last class and some basic concepts we have done. And we will now resume from there. And there certain things we will recall before we proceed further. And those recalls will be useful for me, in fact, for lifetime, if I remember. So we have made certain rules. So I will say we will make some more rules. Last class also I told. And rules related to pointers we have made. So if I said, if I have declared int star PA, and once the declaration is over, so there is some declarations given. Similarly, we will have some more declarations added here. And during usage, subsequently, star and versus not star will have certain rules. So like we have said, R1 we have made that if I use PA without star, and whenever I use star PA, that is with the star, then what is the meaning? Remember, star PA always mean that it is value at address, at memory location or address pointed by P, where PA points. On the other hand, PA is address of the memory location. So remember always, we will be always referring to this address of the memory location where PA points. So these are two rules we will remember, and some more rules we will make, R3, R4, etc. And then I'll keep on writing those rules also. So if you recall this, remembering that accordingly, we have seen the call by value, call by reference also. And I told you to try to give the programming related to stack and queues implementation via parameter passing, where a top or a top will be needed in case of a stack to be passed as a call by value and a call by reference. Similarly, rear and front to be passed as call by reference for the queue operations. Now, resuming further, last time we have also seen that your array name was, we have also discussed array name as address or as a base pointer, as a base address or, but as a constant pointer. That concept also we have discussed last time, and we will reuse that concept also for subsequent discussions. In fact, once I know this thing versus other things which we have just seen, then we can use these things with pointer arithmetic. So till now we have used pointers for the normal operations, but I can also do the operations on arithmetic operations on pointer also. To be precisely, plus and minus are allowed. Plus, plus, minus, minus, they are also indirectly increment, decrement. So these operators are allowed to be done on the pointers. Of course, star and divide, etc. not usable, but these are allowed. That means I'm allowed to write PA plus 1 or PA minus 1 or PA plus plus or minus minus PA, or in general PA plus I or PA minus J, whatever. All these are valid syntax for this, but how they will work? They are somewhat different than your normal arithmetic. Then what your digit-based or numbers arithmetic, what we have understood already, it is slightly different than that arithmetic. Why? The reason is simple, that when you write PA plus 1, and if you have a normal variable x plus 1, x plus 1 always meant if x was a 10, then x plus 1 means 11. No doubt about that. But if a PA plus 1, if a PA is, let's say, 1000H, pointing to some memory 1000, having some data, PA means an address, rule R1. So PA plus 1, you could think that it will mean 1001, but not always. PA plus 1 could mean 1001, it could mean 1002, it could mean 1004, it could mean 1008, etc. All are possible. The reason in this case is pointer arithmetic works as per data type. So that is a new concept which we are learning today, that your pointer arithmetic doesn't simply mean to increment or add 1 to this, it will mean as per data type. So PA plus 1 will mean go or point to next address for, or point to an address for the next integer, for the next element of that data type in general. What does that mean? That data type based increment will happen. It means if you had initially PA here for some information, it may be array or it might not be array, doesn't matter. But if this much space was needed for storage of data element, this storage size is dependent on data type. Accordingly, PA plus 1 will mean next to this. Yes, it will be more clear once I come to the discussions through specific data types. For example, let's take the int data type. Say I have int star PA. If I have int star PA and at present, let's say PA initially will be garbage. If somehow you have made PA to point to 1000H, let's assume once it is pointing to this, so PA has been assigned address of some variable, etc., whatever you did, and now it is pointing to 1000H. So this is 1000H where you have some data. If you write PA plus 1, it will mean 1000 plus 1 into size of int, data type based. Because your int data type was there, it's the same. So if on some computers the size of int could be 4, so this will be equivalent to pointing to 1004. This becomes PA plus 1 because the 4 bytes are being used for one integer storage. So indirectly meaning pointing to the next integer. So PA plus 1 means point to next integer. If it was int star PA. If it was a float star PA, then PA plus 1 will mean point to next float value. So data element or data type based increment will happen. If a float takes 8 bytes, same 1000 plus 1 would mean 1008. So internally, arithmetic will always use the size of a variable. If you write PA plus I, internally this will be equivalent to PA plus I into size of the corresponding data type. Whatever data type you are using for PA, this much will be internally done. And it will be always added, or this will be always added to the expression. So remember this concept, hence it is different than a normal arithmetic. And similarly, the same concept applicable for plus plus, minus minus, minus, etc. So I say I make now a rule R3. PA plus I means increment by I elements, not I bytes. So it is data type dependent automatically. So PA plus Y will mean point to ith element beyond address PA. Beyond address PA and ith element as per data type. So this increment will be always there. So I will note down this R3 into my rules state page also, that PA plus I is still an address, and this is increment by I elements. So this is still address or points to ith element, not byte. So I'll say elements, not I bytes. Remember this thing always. Points to ith element beyond address PA as per data type. So this rule R3 now we have got more. Knowing this rule, this will help us significantly in my array access also. And array versus pointers become quite useful. Knowing this concept makes a lot of sense for the arrays. For example, if I have declared int ARR 50, I know ARR is a pointer. So I know it is having 50 elements from 0 to 49 as a contiguous memory. I also know ARR is a constant address or the 0th element's base address. But now I can say, I can declare another variable, let's say star PTR, means PTR is declared as an address. Now PTR is to be assigned some address. And we can definitely do this also. Because ARR is an address, base address. PTR is also address. So PTR can be assigned as address. PTR as per rule R1, it is supposed to be given some address, and ARR is address. So it can work. It is also equivalent to say that PTR is nothing but it is equivalent to ampersand array 0. With ampersand, we are more comfortable. We know this was one integer variable, address of that integer being assigned to PTR. So, but all these statements are equivalent. So this statement also you can easily use. Not only that, now PTR plus 1 or PTR plus I can be used to refer to various elements of ARR. Let's see that concept more clearly. I say this is ARR. This is bound to this address, so I'm just showing it written at this place. This is index 0, index 1, and so and so. So at present, I said PTR to point here. Then automatically this address becomes PTR plus 1. If a PTR is, let's say this address is 5,000 hexadecimal ARR. So PTR also gets a 5,000. PTR plus 1 will mean not 5,001, but next element. Or in general, I can say PTR plus I becomes address of ARRI, because it will point to ith element. Now, using this concept, I can say your array can be used via pointers. And it can be used via pointers, and of course, it can also be accessed without any square bracket use also now. It will be possible because I will use this. ptr plus I becomes address of ith element if I want value at that element. So a double r plus I is address. I want value of this particular element. So how will you get the value? You can use a star. Star means value. This is rule R1. This is rule R2. So star will mean the corresponding value. So this is going to be equivalent to a double ri. So any address or PTR, I'll say if it was a PTR, you will say PTR plus y. So PTR plus I will mean the corresponding value at that location. Remembering this concept, now let's go further and use this for some good programming. Let's say I have declared a double ri, a double r50. I have also declared some PTR. Now, I want you that find max out of this array, out of n elements array, without using square brackets at all. Only in the declaration you have used, and I don't want to use this, and you have to find maximum out of n elements. So maximum out of n elements, I will say, let's try some method 1. I'll tell you what is method 1. So I will say use PTR to have the base address that you can know the syntax how to do, and then use PTR plus something for referring to individual elements, address of the individual elements, and accordingly. So I will give one option as this. Second option that also I am telling you to try, that is method 2. I say it is possible that PTR plus something or PTR plus 1 or 2 or whatever you write will mean PTR doesn't change, but you use plus 1, 2, etc. I can have a PTR as a base address, and then you can do plus plus to PTR to point to next element, and based on that do the maximum finding. So every time you can have PTR to point to current element. Current element being compared or being considered, you can always make that it should point to current element always. So I will say, now I am giving a pause and try to do these 4 or 5 lines code. Find max using method 1 and method 2, both. I'll give a pause here and give you time to try that. Those who have completed, or those once you have completed, then you can resume your video, and I will be soon starting with the solution. But those who want to try, pause the video and try that. So, assuming that you are ready now to look at or verify your solution, let's see that. I said I have int a double r50, all those variables as declared. So I can say PTR to point as a base address. How to do? PTR equal to what? Base address. A double R is base address. Perfect. Then what? Now I have to read first of all elements. So scanf, etc. n is to be done. So I will do that. Yes. then I have to read the full array. I equal to 0, I less than n, I plus plus. How to read it? So for reading this array, what you can do, what you have to do is that now you will say, I will be reading using pointer arithmetic. That means PTR plus something. Scanf %d. Earlier you were supposed to write an address. For the first element, the address is your PTR itself. For the next element, address is PTR plus 1. For the next element, PTR plus 2. In general, I can say PTR plus I is the address. I easily know that PTR plus I is the corresponding address and no ampersand needed, because this is itself an address. Maybe I complete my reading and then I want to find maximum. So maybe I can assume maximum equal to the initial value via PTR. If I write PTR, it means the address R1 rule. This is the array. So you have read values 5, 19, 3, 11, and so and so. PTR is here. Now, if you have a PTR here, PTR doesn't assign to max the value, but max is a variable of integer variable value type. PTR is an address, so we need value to be assigned. Value at which PTR is pointing, that is star PTR2, as per my rule R2. First value being considered as max, and then with remaining values, I will be comparing and finding. So compare. Earlier, I used to write if max is less than, earlier I used to write here array I. Now I need to write something different. But if it is there, then I said max to be updated. Earlier I used to update it with array I. Now I have to write something different. Max to be compared with the value. That means with the star guaranteed. Star and brackets. What is the address of ith element? The address is PTR plus I. So I can say max will be also updated with PTR plus I value. And once I come out, my max is ready to be printed. So effectively what I have done is I have used star PTR plus I instead of ARRI. And that will do the whole work for me. Let's go to method 2. Method 2, where I said we would like to use pointer arithmetic. If I want to use pointer arithmetic, let's assume initially I have done the base address to be PTR equal to ARR. For the time being, I'll say, let's assume reading has been done correctly through any method. So I will say once the reading has been done, reading of all n elements is also completed. So I just want to find the maximum. So my focus is just find maximum. So I will say let PTR be given address. And I don't want to use a scare bracket. I don't want to use plus I. Plus I will not be used. Scare brackets will also not be used. That means PTR must point to the current element being considered. I want max to be initially the current element. As we have already done, max equal to star PTR. So this was ARR, not a address, ARR, sorry. So max equal to star PTR. Now I have to compare. For I equal to 1, I less than n, I plus plus. I want if max to be compared with current element. If his max is less than current element, I always want PTR to point to current element. Star PTR will become the value of the current element. So I want to compare with this. Currently, I am talking of element to be ith 1, I is 1. So my PTR should point to first element. At present, it is pointing to 0th element. So I will say increment PTR. Say PTR plus plus. So by this statement, I am able to increment my PTR to point to next element. Compare with this. If max is lesser, max will be updated and repeat the process. Again, you go back. PTR will be again incremented. Initially, here you have 5. This is your PTR pointing to. You made plus plus. Plus plus made, PTR started pointing here. You again made plus plus. In the next iteration, PTR will come to this current location. So PTR plus plus can be the way of doing this method. Then, through this process, I will use another method now. Method 3 I will define. No PTR variable to be used. No extra pointer to be used. No scare brackets to be used. And still I want the coding to be done. I say method to be refined. So you have int ARR50 and int star PTR not allowed. No, you can't take extra variable. You can't do scare bracket use subsequently for comparison. Reading, etc. you complete. Reading done. I want find max with these rules. Think over this. How to do? Just recall ARR is also a pointer and pointer arithmetic will work via ARR also. So again, I'm giving a pause here and asking you to try. I say the way you did method 1, similar method can be applied using ARR as a pointer. And that can become method 3. So this will become method 3. I ask you to try that and just give a pause here. Just pause your video, try that. Once you are resuming, the solution will be discussed. So I am aiming to find max now. So if you have resumed, let's see the solution or verify what you did. Max to be initialized. With whom? Earlier we used to do with ARR0, but I'm not allowed to refer to ARR0. I will say at present ARR is guaranteedly the base address. So star ARR will be the corresponding element. For I equal to 1 to n, you have to go I plus plus etc. Earlier, you used to write if max is less than ARRI, but scare bracket not allowed. PTR plus I, I'm not allowed to write PTR, but I say ARR itself is a base address. So ARR plus I becomes your address of ith element. Because ARR is base address, ARR plus 1 will mean next element's address, ARR plus 2 means next element address. So effectively it means this becomes address of ith element of the array. Because your array is base address. So if you are able to compare with this, max will be updated. And whatever you want to do, rest logic you can accordingly continue. So this method is exactly same as method 1 with ARR used instead of PTR. This becomes method 3. So method 3 has been discussed. So I have already discussed method 1 where we used PTR and PTR plus I. Method 2 we used PTR plus plus to be used. Method 3 we have used ARR plus I. Method 1 based method 3 was defined. Can I think of making method 2 also to be refined towards method 4 using ARR plus plus, the way we have done PTR plus plus? I can think of making the another implementation using method 4 with ARR plus plus. What do you feel? It will be similar and exactly as possible? Yes, appears okay, but I say no, incorrect. Because ARR is a constant point. So increment to ARR is not allowed. ARR plus I is okay, but ARR plus plus is incorrect. ARR plus 1 can be okay. Why? ARR doesn't change when you write ARR plus 1, but in ARR plus plus, ARR also changes. So having said that, now we know these 4 methods and we know certain new rules also. So let's refine and rewrite few more rules. So we have rule R1, R2, R3 already with us. Now I define rule R4. And for R4, I say I have another variable declaration. Let's say ARR 50. So during declaration, I have done ARR. In this case, ARR is always a constant and base address of memory of contiguous memory. This is guaranteedly a contiguous memory. 50 integers, int elements. Not 50 bytes, 50 integer elements. So remember that it is now integer element. So this we have already done. Constant and base address means starting address out of this 400 bytes or 200 bytes, whatever. If integer is 4 bytes, so it is 200 bytes, and it is a starting address of those 200. Secondly, now we have indirectly seen that ARRI is actually nothing but it is equivalent to, say, star of ARR plus I. And to be precise, internally, the working is via this. So internally, your ARRI always works through pointers. At the OS and hardware and system level and compiler level, all your ARRI statements, they get internally converted to this because ARR is base address plus ith element to this, and this becomes address, star of that becomes Y. So remember this rule R5. So effectively 5 rules which will be sufficient to understand pointer with all concepts which we need. But I will give one more rule and then we will proceed. That rule R6, whenever you use star PTR or star of some variable, star PA, maybe plus something or whatever, anywhere you use a star with a pointer variable, some internally address whatever you are saying, this PA plus whatever you have written must be a valid address, and valid means address of memory location of some variable which is your variable, corresponding to your variables, your program's variables, which are currently active, which are currently usable. This address must be always a valid address. Otherwise, if it is not, your program will crash. Abnormal termination will happen. If you try to access via pointer any memory location which is not a legal or valid location for your program, the program will crash. So pointers are very dangerous. If you use incorrectly, your program will terminate abruptly. So don't do that always. Remember these rule R1 to R6, things will become so easy for you. Then coming last discussions for today's class is dynamic memory. Till now we said what we have done is arrays were used as pointers. Now we can use pointers as an array also. So it means memory allocation during runtime. During execution only, memory will be allocated. Other variables like arrays, etc., they get memory during compile time. So when the program or function starts, the variable gets memory. Like if you have declared one variable array in main, main will start and array will get memory. Till the program, till main doesn't finish, the memory remains allocated, fixed memory remains allocated. So if you have written main and declared int ARR 5000, 5,000 bytes got allotted at the start of main. Till main doesn't end, this memory will remain assigned. As soon as main is over, this variable will get free, memory will get free. But it is assigned during compile time. So runtime, we are not dependent what n you will give. You give n as, let's say, 7. Out of 5,000, you will use only 7 values for your storage, etc. maybe, but 5,000 will remain allotted. Dynamic memory will free you from those problems. For example, you have main. In main, then you have scanf and done. So first you will declare, let's say, int star ptr. And then let's say you do scanf. You want an array, but first you know the size. Let's say you gave 10. If you gave 10, you want array of 10 elements and then you want to find average of those numbers. So for that, now you can use a dynamic memory. How? You can write malloc statement. So malloc is a memory allocation statement, and how to assign n multiplied by size of int to be written here. Because how many bytes you want to allocate, malloc needs to know. Malloc needs to tell how many bytes. So how many bytes you need is to be passed to this malloc function, and that is what we have passed. So hence the size of int must be written, because on various computers int may take a different bytes. On one it is taking 2, on others it may take 4, some other 8. So if you want a 10 integers, some computer will require 20 bytes, some will require 80 bytes. So accordingly, those many bytes to be allotted. Then here you are supposed to write the typecasting. And this typecasting means these 40 or 80 bytes are to be considered as pointers pointed for integer storage, multiple integer storage, and integer storage. Again, why do you need typecasting? Because malloc returns memory of void data type. So it can be used for any data type, and it will return you the memory of void data type. That memory void means you got 40 bytes, 50 bytes, 80 bytes, but whether these are equal to 10 integers or 40 characters or 20 floats, your typecasting has to decide. And typecasting must be of the same data type for which we were using the pointer. So this is a correct syntax. Of course, flexibly, you can probably play with these things, but pointers are dangerous. Any incorrect or any ambiguous statement used without knowledge can be dangerous. It can crash your operating system, it can crash your code definitely, and there can be a lot of side effects. So thumb rule is always do proper typecasting, supply proper size, and assign the pointer of the same data type through typecasting. If it was PTR is of int type, do typecasting with int star. If it is float, do typecasting with float star. Typecasting is must because by default malloc returns void. Knowing this, once this is done, I say through this process what I have achieved is, now let's say if a size is 4 bytes, so you achieved 40 bytes. Via malloc statement, you got 40 bytes returned, and your PTR points to this location. Let's say this location is 8000 hexadecimal. So your PTR variable got address 8000H. And now these 40 bytes exist. Before typecasting, these are 40 bytes. Before typecasting, these are 40 bytes. But after typecasting, they will become logical 10 groups. After typecasting, it knows that this 40 bytes is to be considered as a collection of integers because it is an integer pointed memory. So it will say this is 1 4 byte, another 4 byte, and so. And this is indirectly 0th element. This is first element, and this is 9th element. So indirectly, this logical boundaries or logical grouping gets created as per data type. And the purpose of all this you can easily understand is PTR arithmetic will work. For example, if you write PTR plus plus, PTR should point to next integer. If a proper typecasting is done, automatically PTR plus plus will mean next integer element. And next integer element is at which location? These boundaries have been identified, and it will all happen smoothly. Otherwise, there can be certain explosive results because of incorrect use of pointers. So knowing this, I say now all this will work smoothly without any problem. And I know these are 9 or 10 integers indexed with 0 to 9. Indirectly now, after this, things become easy. PTR can be used as an array. Array of n elements. In this case, n is a 10. So now for all purposes, you can treat this as an array. For all purposes. So now we say effectively pointer can be dynamic memory allocated pointer and then dynamic memory allotted once. It can be used or it becomes a pointer, becomes an array. So earlier we used array through pointers. Now we can use a pointer as an array. Meaning that once you have done this, your syntax PTRI will also be correct for all purposes. Why? You know easily PTRI by rule R5, it is equivalent to say star of PTR plus I. By rule R5, we have already written this is equivalent to this. Whenever you write this syntax, internally convert it to this syntax. And once you convert this to this syntax, PTR is a base address. Starting address of this location is a PTR. Plus I means go to ith element beyond PTR. Star means value at that PTR. So for all purposes, this becomes easy. Then based on this, I will say, now let's try to write some more programs. And what program to be written? I say now find average of n elements using dynamic memory. And don't use square bracket at all after malloc. So I'll say do this. And this, of course, again, I will say there is a method one, which of course you will use via PTR plus I, as you know. Then I'll say, can you think of another method too, where you can use concept like PTR plus plus, and in this case, the pointer to point to always current element. Very similar what you have done earlier. Try that. The only thing in this case is now, because before dynamic memory reading cannot be done, so you have to read n. After read n, then you will be doing a dynamic memory allocation. But after that, reading of n elements has to be done. You can't assume that has been done. Reading of n elements to be done, then average to be found. So I will say for both methods, the same process to be done, and do this, give a pause to this video, try that. And once you are able to complete, you can verify some of these discussions, which I'll write here. So those who want, they can pause and see. And once you resume, I will give method 1 solution and method 2 solution. So I will say fine. If you are ready, I am going to write the solution. I have read n. I do PTR equal to the malloc statement as per the proper syntax. I am not writing again. Once PTR is ready, now I say for all purposes, PTR can be used as an array. Effectively means for I equal to for I equal to 0, I less than n, I plus plus, and via this, I will say scanf. Scanf percentage D. Of course, you will use ampersand, earlier array I. Now I can write a PTR I. Perfect. So I said don't use this statement, I'll correct. Don't use star at all. Pointer syntax don't use, because pointer syntax we are avoiding. Don't use pointer syntax. So if by mistake you couldn't understand, just pause video now and try this. I want after this always no pointer, although it was declared as a pointer, but subsequently use square brackets, etc. No pointer at all. Star will not be used at all. So pause this, resume once you are ready. So if you are ready, I'll say, yes, this could have been the reading. And after that, say sum to be found. So I can say sum equal to 0 for I equal to whatever 0 onwards you will write. I'm not writing full code. What I need is sum equal to sum plus the square bracket syntax, no star. So I can say easily you can see PTRI. Perfect. And then once the sum is ready, average can be computed by dividing sum divided by n. Of course, integer division happening, so fractional value lost, but you can correct that if you need. More importantly, I said method 2, that use PTR++ and then use square bracket to refer to the current element. So if you want that to be done, how will you use? Or if I don't want to use star at all, how will you use? So star is not to be used, square brackets are allowed to be used, but I don't want plus I or this plus also to be used somewhere because pointer can change. So of course you will do malloc, etc. So I say earlier I was saying for I equal to 0 onwards, the scanf to be done. But I say after scanf, what I will do is I will do PTR++. I want to use PTR++ always after every, so that PTR points to always the current element being accessed. Initially, PTR is base address, not an issue. So PTR has got the malloc with proper syntax and automatically it is pointing to the base address. So base 0th element. Now I say scanf to be done. So what I should write here? Now earlier I wrote PTRI, but now I say every time PTR points to current element. So current element's address will always remain PTR. This is always current address. PTR being incremented always and being used there. Similarly, for finding sum, you could say sum equal to 0, and then you could say for loop, and then you could say sum equal to sum plus something to be done, but after that I want PTR++ also to be done. This is must for me. If it is must for me, what I am supposed to write here? Not PTRI, because PTRI means PTRs and then ith value to that. Now PTR always goes to current element. This points to current element. At present, my PTR can be used. So probably current element's value is what I want to use. So I say first time it is pointing to 0th element, that value to be used. Later PTR points to next element, that value to be used. Then PTR will point to again next element, that value. And pointer being incremented every time. This looks to be perfect, but there is one problem. Can you identify the problem in the method 2's code? The problem is, can you think where is PTR pointing now? Once you reach to this statement, where is PTR pointing to? Via scanf, PTR was incremented. Initially, PTR is here to this element, but PTR++ being done every time, PTR finally will read nth element, that is at n-1 location. PTR will read this, not only read this, after this again increment. So PTR now points to out of this memory. In fact, we have gone beyond this memory. So, but PTR is at this address. So if it is at this address, the PTR must be brought back. One way could be you will say, okay, assign PTR equal to base address, but we have lost base address. We are not supposed to again dynamically allocate, memory already exists. So that means PTR needs to be shifted. That means we have to write PTR equal to PTR minus something. You must write this statement to bring your PTR back to the starting element, and then your for loop will work. So I will stop here and asking you to try all this. Another way could also have been that method 3 for this also could have been there, that for scanf, you are using PTR plus plus always, and for summation, loop, etc., use PTR minus minus concept some way. Keep on traversing backwards, keep on reducing PTR one by one, and like. So method 3 also can be there. So I'll wind up and stop here and showing you finally the rules once again and then giving you the homework. So here are the corresponding rules to be remembered always. I'll say now I'll put rules as this one so that you remember always. And rules are here. If you have declared like this, PA means address of memory location, star PA always means value at that location. PA plus I is increment corresponding to data type by I elements. So pointer arithmetic is a data type dependent. Whenever you have declared array, this variable name is always a constant pointer and the base pointer of the contiguous memory. ARRI is always equivalent to star of ARR plus I. Sixth rule, whenever you use a star with some pointer address, the address must be a valid address, and valid means corresponding to your own program's variable, not randomly to any garbage location, not randomly to any outside location. So it must be always pointing to somewhere which address you have assigned. It must not have gone to some random or beyond the address range which has been permitted. Having said that, I will say now homework. Effectively, simple homework for finding max. I have told method 1, method 2, and method 3. Implement all these 3. And similarly, for finding average, I have told method 1, method 2, and method 3. What has been method 1? Here I said that I am going to use the concept of something like PTRI. Here I said I will always use PTR plus 1 plus plus during scanf also, and based on that some programming to be done. So after this will be done during this, and then PTR to be reset by making PTR minus something. And during summation also, you will use PTR plus plus in the loop. Method 3, I said PTR plus plus you can use during scanf. So this is during scanf. I said use during scanf PTR plus plus, but during some loop, use PTR minus minus suitably. Similarly, related to max, what was method 1? In method 1, we said that we are going to have the maximum found via PTR to be used. ARR array declared, ARR used, and I said PTR plus I based programming we will do. Method 2, we said PTR plus plus will be used for the purpose. And method 3, we said ARR plus I to be used. And method 4 was incorrect, where ARR plus plus was not to be done. So having said that, I will say now you have a lot of learning done. Practice all this, try this, and again I will say also read from the book, the pointer chapter. From a C book, any C book, any good C book, any good book of C programming. You must read pointers chapter. That will consolidate your knowledge and concepts. And pointers need a lot of concepts. You should not just blindly or ignorantly use these. So read this carefully and remember those things along with R1 to R6 rules. Having said that, I will stop here. Bye-bye. All the best to